This is Professor Russell Wilson on behalf of Wyzant. Given the question here, differentiate using the quotient rule. The function is we're differentiating cosine x over x. Quotient rule is derivative of the first times the second minus the first times the derivative of the second over the second squared. So say derivative of the first, the derivative of cosine is sine, negative sine actually, times the second minus the first cosine, the derivative of the second is 1. So how about giving us negative x sine x minus cosine x over second squared, which is x squared, the whole thing in a nutshell. Now, usually when I think about dy dx, I'm usually thinking about getting the slope of a line. So how about doing a slope of a line, something extra, doesn't cost anything extra. And the nice thing about trigonometry is you don't need two coordinates, just as one little place to do a slope of a trig function. So how about at pi over 2, for instance? So we plug in pi over 2, that would be negative pi over 2 times sine pi over 2 minus cosine pi over 2. Since sine pi over 2 is 1, I get negative pi over 2 times 1, and cosine pi over 2 is 0 over pi over 2 squared. So how about a negative pi over 2 over pi squared over 4? Flipping it around, I have a slope of a line would be negative 2 over pi. For instance, if I decide to do that slope, I would be going downways a little bit on that particular trig function. But all that to say, the answer to the original question is dy dx equals negative x sine x minus cosine x over x squared. Or you could write it negative x sine x plus cosine x all over x squared. Your teacher wants you to clean it up really, really good. Usually the higher up in math you go, the less you have to clean it up. So at any rate, that is using the quotient rule on cosine x over x.